Well, first of all, welcome to the Encode StarkNet Hackathon. I'm Jake, I'm the program manager, so I'll be kind of your point of contact. And I've already probably sent you all one-on-ones or emails, and we've had a couple one-on-one calls as well. So keep just booking time on my calendar if you've got some time. I love chatting to you guys. The more the merrier, the more I get to learn from you guys, the better it is for me as well. So as Anthony said, thanks for joining us from around the world. I think that's what's so awesome about Web3. We can have people from around the world, and it's a great community to be a part of. Just a quick rundown of today's events, as Anthony was also saying. I will be running us through a quick couple info about the hackathon, and then we're going to go over to Anthony. He's got a couple words of wisdom for you. He's seen many a project in a hackathon, so it's always great to hear from him. And then we're going to go over to Henri for the workshop, and he's going to say a little bit more about StarkNet as well. So it's a little bit about Encode to start off. We are a Web3 educational community. We run programs like workshops, boot camps, hackathons, and accelerators. Hackathons are both on in person and online. And kind of our goal as a company is to be a place for ambitious, talented people such as yourselves, and just to be able to get you to achieve your goals personally and within maybe your project or within Web3. And we kind of achieve these by our programs that we run. So how does a hackathon run in general? I think it's a good place to start. The main point of a hackathon is actually to build something, normally to have something live and to have a bit of code behind it as well. Secondly, I think the point of this hackathon is to learn a lot as well. There's quite a few workshops coming up, and it's to kind of learn about new protocols and working on new protocols. And I think this is going to be an unbelievable opportunity to work in a hackathon with StarkNet. So kind of what is the StarkNet hackathon? First of all, it's something really unique to us. It's our first hackathon that is on a layer 2 network, so we're super excited about that. But basically, it's a 5-week hackathon to build a blockchain project, and there's unlimited support available. It's to learn about blockchain through StarkNet and through their unbelievable workshops. There's many different challenges. I'll go over them in a couple minutes, and then if you do well in these challenges, there's prizes to be rewarded as well. Just heading over to the schedule. I'll just run over it quickly. Kind of have our first workshop, which is today, which is the StarkNet Hack launch and the StarkNet intro. Tomorrow, we're going to have the StarkNet wallet, which is run by Argent X. And then we're going to have a bit of syntax as well after that. And then on the 3rd of March, we're going to have the StarkNet ERC20 and ERC721 workshop. Then on the 10th, we're going to have the StarkNet JS. The 16th, we're going to have the StarkNet layer 1 to layer 2 messaging. And then finally, on the 3rd of April, that's our submission date. This is always a question that's asked. The kind of submission date is at 1 minute to 12 on the 3rd of April in your time zone. And then on the 11th of April, we're going to have the finale and the prize giving. Just heading over to the StarkNet tracks. The first kind of track is the layer 1 dApp build on StarkNet track. This is building the dApps that are fully live on StarkNet and leverages its ecosystem. You don't need to interact with the layer 2 data or assets. You can get inspired by gaming apps like Bricks or like a marketplace like Oasis. The next one is the layer 2 to layer 1 dApp on the StarkNet and Ethereum track. This is building dApps that allow the interaction between StarkNet and Ethereum through the use of assets and all the data. Think of bridges, DeFi, pooling, storage, or proofs. And then the final one is the Open Track Challenge. This is StarkNet will just have a fund and award different prizes for Open Track challenges. This is also a great place to build different types of dApps. And this is kind of just the prizes to kind of see what's in store if you do well. Obviously, the first track and the second track, there's $8,000 for first place and $5,000 for second place. And then the Open Track Challenge is just a pool of $24,000 that StarkNet will decide who gets that. Just a special shout out to Argent X. They are partners with StarkNet. They are kind of the wallet system attached to StarkNet. And they are joining as partners, and they'll be running the workshop tomorrow, which we're very excited for. Just opportunities afterwards. I think now that at the end of the hackathon, you've learned new skills through the hack, and you want to use these new skills in the real world. I think, first of all, broadly speaking, what we always say in Encode is you become an ambassador for StarkNet, and you become an ambassador for Encode as well. You become a part of the community, and this community opens you up to connections. It opens you up to interacting with other people within Web3. So there's a huge kind of general ambassador kind of feel to the hackathon once you finished it. Encode does have a fantastic recruitment team. So if you are looking for jobs afterwards, we'll chat in our one-on-one calls, and I'll kind of just chat through maybe what the process is, maybe what's good for you, and we can work through it there. But our head of recruitment, Laura, is really fantastic, and we definitely will help out there. And then kind of the last thing is, this is a launch pad for your projects. You get funding to build connections with StarkNet, to build connections with whoever, and hopefully from there one day we'll see some fantastic projects coming through. Yeah, just the resources that are available. You were sent a hack pack at the beginning with your onboarding. A lot of you have asked me this in the one-on-one calls. So if you just go back, you have any kind of questions that are general speaking, just go back to your emails and type in kind of the onboarding process, or just onboarding email, and you'll find the hack pack there. It's got a lot of questions, a lot of answers to your questions. The Discord is kind of our main source of communication. So if you're not on there, please make sure you're on there. It's really crucial. There will be constant updates on there. Finding teammates is on there. A whole bunch of things are on there. The Encode team is 100% at your disposal. We are based in the EU or the UK. We're based in America, so we've got 24 hours almost available to helping you out. And we have a lot of one-on-one calls available, which I'll be running. So please book them with me, and I can kind of mentor you and help you in the right direction for your projects. And then all kind of posts are up on Medium. You would have seen this already, just about the general challenges that are available, and maybe the post marketing as well will be up there. So just make sure you see in your Medium posts. And then obviously we have our events. There are 6 wonderful events hosted in this hackathon. And then all, as Anthony was saying, all events are recorded and put on YouTube the next day. Please try and make them, because it makes it a lot easier for you to ask questions. But we also understand if you can't make it with the different time zones around the world. And then this is also quite crucial. I am personally not technical, but StarkNet has a wonderful technical support, and that will be on the Discord as well. So under technical support, if you've got any questions about your code or any general questions, please just type it into the Discord, and it will come up there. And then submissions is always just something that's asked about, so we just thought we'd do a slide about it. The submission date, as I said, is the 3rd of April. And what you need to submit with the submissions is a link to your online demo, a code base. You need to have a little presentation. You need to have your technical papers, and you need to have a video about your project, which is 3 minutes maximum. We say the good projects can do it within a minute and a half. So that's basically anything to do with submissions. But if you have more questions, we'll chat about it a bit later. And then here's some frequently asked questions that just us as Encode have picked up over the last couple hackathons. So who can take part? Anyone can take part. Do you need a team? You don't need a team, but we can help you get a team. This is either through a one-on-one call. A lot of people have asked me about teammates, or just on the Discord. There's also a little find a teammate and just kind of post on there maybe what your skills are, maybe what you're looking for, and then it makes it so much easier just to connect. And is there technical support? As we said, yes, StarkNet will run the technical support. Where does all organization happen? On Discord. Can I enter an existing project? Yes, you can, just as long as it doesn't raise any significant funding. And definitely, if you've submitted another hackathon, it'll be well worth making some adjustments just to kind of get it in line with the tracks that are available in this hackathon. Yes, you can also build on your own. A lot of solo hackers out there. And can I do more than one challenge? Please, we encourage this. This is just, there's so much prizes available. So if you've got an opportunity, please submit more than one challenge. And as I said, the workshops will be recorded. I've repeated myself quite a bit there, but it's just good to answer your questions. What's a striking theme about this hackathon is kind of the mentorship around it. There's going to be a lot of mentorship coming from StarkNet through all of the events that are going to be hosted in the workshops. And as I mentioned, there's technical mentorship. And then there's what's really unique about kind of Encode is the mentorship that we're going to be able to give as program managers and these one-on-one calls we can have with you. So please, I'll put my Calendly link into the Discord after this event. Book a one-on-one call with me, just so I can go through a couple of things with you. Also gone through a lot of projects. I can kind of hopefully guide you in the right direction. And what's next? Yeah, main thing, join the Discord, as we said, as you can, just a general theme, you can hear that Discord's where it all happens. Find a teammate, same thing on Discord. Join the workshops, the Eventbrites are sent out. So just kind of find the link and get your ticket and yeah, build your project. We're going to hand over to Anthony now. He's got a lot of wisdom. So Anthony, over to you.
Hi guys, thank you very much. Well, first of all, thank you very much for being here and well done. This is, I think, one of the best opportunities you really have in crypto at the moment, the chance to build on StarkNet. So first of all, well done. You've made a good decision. A few rallying words, really. The hackathon for me is the most incredible format in crypto. If you are a would-be developer or a current developer to go to the next stage, maybe it's a product of excitement, the innovation, the funding of the space. But hackathons in this industry are unlike any other. They really are a launch pad on which to get a job, to found a startup, to get funding, to contribute and be at the core of emerging ecosystems. And you don't get more exciting right now than StarkNet and the great work that StarkWare have done to facilitate that. So use this hackathon, use this 4 or 5 week format to learn, first and foremost. There's lots to learn, particularly Cairo, which is an extremely exciting language and one that offers a ton of possibilities, but it requires some work. That's why you have this longer format. And B, build some great projects and know that there are several opportunities waiting for you at the other end, be it grant funding, investment funding, getting jobs. All of this is available to you. We hope you seize the opportunity. And there was a question about unlimited support. Basically, this means we will go as far as we need to. We'll be on call with you every day if we have to. We'll be there 24/7 answering questions. This is the thing you get with an Encode event, that unlike any other, is we really will go above and beyond, and we try and optimize for you spending time with us, even on this online format. And particularly with Jake and myself and Omji and Laura, whatever way you want to go, we're here to help you. And if you look at the over 60 companies that come out of Encode, the hundreds of now people working in the space that have come through Encode across many ecosystems, it all starts with a conversation with us and getting to know you better. So make sure, if you haven't already, to book in a one-on-one with Jake and have a chat, and maybe 1, 2, 3, 4, 5, 6 of those. Maybe just have one, but I think it's an important part of your journey to do so. The other thing is, again, you have, I think, what I always say to people, you don't realize how early you are when you do these events. You are so, particularly in the StarkNet ecosystem, I don't think you'll get this opportunity to have this access to such a rockstar team ever again, really. I mean, I'm sure in a few years, StarkNet will be huge, and the chance to learn from the people you're going to learn from over the next couple of weeks won't really be as simple. It won't be as direct. It won't be as personal. So really, you're early, which is a fantastic opportunity to you, and really seize that with both hands. And the 4-week, 5-week format is designed in part to allow you time to invest in yourself. It's not like a traditional weekend hackathon. It's very intense and you can't build much. This is really to allow a period of digestion, proper investment of time, and also to allow you to fit it around other commitments, so that even if you are a developer working 60 hours a week, you still can find a little bit of time to contribute to this and to learn. And I think this is extremely important. So use this format, go at your own pace, attend the workshops. We always say that it's great you can watch on YouTube, but come live, ask a question, go and speak directly, come with some preparation work done. We'll be sending some preparation work as well for you to do, and come and ask questions and check it. and really use that engagement time for the to make your end thing you build in the hackathon better. And the most important thing as well, I think the people you meet in these events tend to be your friends for life, even on this online format. So please be active on the Discord, be active with us. It really does. Turning up and being active and being the first one to say hello always does win, actually. So we hope you do seize that as well. That's broadly it from me. In terms, I do like to talk about aftercare a little bit because it's where we thrive. We hope this is not the end of your involvement with Encode and indeed StarkNet. We hope this is a launch pad to future things. Encode itself has a dedicated investment fund. StarkNet and StarkWare has funding there available to provide to you if you go and build something fantastic that's going to contribute to the ecosystem over the long term. If you want to get a job in the space, we have Laura, our dedicated head of talent, that will help you get a job, we hope, within maybe a StarkNet company portfolio or attributed company would be fantastic. I know there's a lot of demand for us at the moment. But in general, there's a lot of stuff waiting for you afterwards, and we'll be there to help you. That's it from me, really. If you want to find me, please feel free to email directly. I'm the founder, one of the founders of Encode, the CEO. So if you ever want to discuss anything, my calendar is always open and my door is always open, but feel free to drop me an email. You will, last thing to say, you will be getting an NFT certificate for partaking in this program. This is just to, it will be linked to how you do in the hackathon, but you will get one for participating in the program. You get them for every Encode event. We're about to roll them out historically and kind of signifies your involvement in the Encode community. Yeah, hopefully it'll be even more rewarded later. But you will be getting a special NFT for registering and taking part in this event. And the further you go, the better this NFT will be. Good. That's everything from me. I'll be sticking around, of course, if anyone has any questions directly. But well done again for joining, and thank you very much. And I hand back to Jake, who I think is going to introduce the fun bit of today's workshop, the actual technical learning.
Yeah, so it'll be very quick. But yeah, we're over to basically Henri. We've been working with him for the last couple of months. Yeah, really awesome to have Henri here, and thank you so much for the partnership between Encode and StarkNet. Yeah, so over to you, Henri.
Hi, happy to be here. Thank you for your time. Thank you for the great work we've been doing for the past 2 months. So I'll just say a few words, and then I think we'll back to submissions, and then I'll talk more about the actual topic of the workshop tonight. But about the hackathon itself, I first wanted to say like a big thank you. Actually, 2 thank yous. One to Encode. It's been a pleasure working with you, organizing this workshop. You guys obviously know how to throw a hackathon, and it's great to see so many people show up at the party, and I can't wait to see what come out of this hackathon. The second big thank you is to all of you, the people who are here in attendance. You guys represent the scarcest resource in the ecosystem right now, which is brain time. That's what we're after. We know there are a lot of exciting things to be done in this ecosystem, in the blockchain space, and some things are harder to find than others. There's no shortage of capital, but there's a lot of shortage of smart people, and there's a lot of shortage of people with time to spend their brain power on cool things. So I really appreciate you showing up tonight and being with us for the next few weeks to learn everything about StarkNet. So I'm Henri Lieutaud. I'm a developer advocate at StarkWare, and I work specifically for StarkNet. My job is to explain what StarkNet is and help people get a grip of it. So to which we have concocted a big program for you for this hackathon. I'm not gonna lie, there's hours of work for you to learn in depth how Cairo works, how StarkNet works. You don't need to do everything, but we've made it so that if you want to spend a lot of time diving into our resources, you'll be able to. Don't hesitate and ask a question. Here's my Twitter account. You can send me a message, or here's my email. Don't hesitate and ask questions. There are no stupid questions. There's just lacking documentation. So make sure to tell us where our documentation is lacking so that we can make it better for next time. This is the first hackathon we're running, and as Anthony said, you're still early. I think that if you stick around for these next sessions, you'll probably get the same excitement as I do. ZK rollups in general and StarkNet in particular really do represent the next step in the blockchain space. It's kind of like going from black and white movies to Technicolor, and I'm really weighing my words here. So do stick around, imagine cool stuff, and reach out if you want to build cool stuff. And yeah, I'm just super eager and happy to be working with all of you for the next few weeks. Thank you.
Okay, perfect. Thanks, Henry. Really appreciate that. We covered everything in the first little bit, so straight
So
back.
I can go ahead and explain what
go.
StarkNet is. Wonderful.
Let's do
Okay.
it. The big stuff.
Wonderful. Pretty cool. So okay, so I'm gonna keep an eye on the questions going here. So just to make sure I don't miss any, give me a sec to see if I've wasted something. Okay, so Jeffrey is asking, where do we learn Caro? I'll get to it. This is tomorrow's workshop, actually. Tonight we'll talk about how StarkNet works itself, the network, what it is, what you can do with it, why it's different than what you are used to using, and we'll dive really into Cairo tomorrow and on Thursday. What's the best wallet to use? Argentex is the easiest one to use today, for sure. And dumb question, can you explain ZK to me? We'll try by the end of this session. If you ask again, I'll try to explain to you like what is ZK, how do ZK Starks work. And okay, so there's a question, what's my background? How did you get into ZK StarkNet? So I studied engineering. Initially, I studied electronical engineering and embedded system. I worked in telcos for a while, and then I switched. I mean, on the side, I started learning stuff about blockchain, kind of like what you guys are doing now, I guess, because I know a lot of you are not yet into the blockchain space. And I made the move to full-time blockchain stuff in 2017, I think. Yeah, and I worked in the insurance business for about 4 years on blockchain-related topic. I mean, on blockchain stuff, but for insurance companies. And I joined StarkWare about 4 months ago. I've always been curious with how you can scale Ethereum, and what got my attention is that there's really something different here. I'm obviously not objective anymore, but I like to think that that is indeed the case. Okay, so and yeah, also something I wanted to mention, what's my background? How did I get into ZK? Maybe the underlying question here is, are you a mathematician or a hardcore cryptographer? And I'm not a big cryptographer. And I think one of the big mistakes people do when they think about StarkWare, StarkNet, is they think it's some kind of impossible to master moon math tool. And it kind of is, but you don't need to know deep down the mathematics and the cryptography behind it to make a really cool use of it. Kind of like how all of you who are writing smart contracts use cryptographic primitive, but don't really need to know all the details about how they work in order to make a good use of them, right? Okay, so I'm going to share my screen because I have a small presentation. Really cool. Okay, so as mentioned, tonight we dive on what is StarkNet, how it works, and what are ZK rollups in general. And tomorrow we'll dive on to in Cairo. Okay. Something I wanted to mention also, but I'll go back to that later tomorrow too. The material we've prepared for you to learn Cairo are really based on existing Solidity blocks. So basically, they're made so that you can easily transfer what you know in Solidity to Cairo. Yeah. So why do we need ZK rollups in the first place? What problem are they solving? The main thing that stands out here is that Bitcoin, Ethereum are relatively recent tech. We're less than 15 years old, less than 10 years old for Ethereum. How come you can do so much transactions on Alipay, on Visa, but you can't really do the same kind of volume on Bitcoin. Why can't Bitcoin or Ethereum have the same kind of performances than credit card and bank? And it really comes down to the core of how it works, which is basically what we like to call accountability or inclusive accountability. The way your bank works, for example, is what we call delegated accountability. You really don't really check what they do. You expect some people will, specifically the state, but they don't really have a tool to do it in real time. So controls are sparse and they're not very based on code. They're a lot of time based on paper because the way the backend of banks work today is still very much the same process-wise as it used to be 50 years ago, right? So basically you have a big database, a big server, which is operated by a single party or a bunch of small parties, which do all the workload for everyone, right? And this allows them to scale very easily because since there's only a handful of them or just one of them, when there's more volume, well, you just throw a bigger machine at it, right? And it's pretty much solved. Blockchains on the other side are what we call inclusive accountability. They don't rely on a single party to process all transaction. They expect everyone to process each and every transaction of the network, right? It's the old don't trust, verify, right? You don't just take something for granted. You will always be the one that will verify your transaction in the end, and you'll be sure that the information you receive is the correct one. The problem with that is that you get more guarantees in the manipulations of your asset, but you're sacrificing privacy and scalability. In which sense? In the sense that oftentimes people call the blockchain distributed ledgers or distributed computings. Blockchains are not distributed ledgers, they're replicated ledgers. They're the same everywhere. The workload is not divided amongst players, it is replicated everywhere. So here you have a first instinctive hint as to why blockchains are more expensive. When you do a transaction with your credit card, it is executed and validated by one party or just a small number of parties. Okay, so trusted party, you have delegated accountability. Blockchains, you have inclusive accountability. The issue is, once again, you sacrifice privacy and scalability. You sacrifice privacy because now everybody gets to see what it is you were doing on the network. Since everybody has to validate what it is you were doing, then everybody gets to audit your transaction, see what you were doing. You can't think, oh, okay, it's just a handful of parties. I don't mind if they know what I do and the others will not know about it. Everyone knows about what you're doing instantly. And then you sacrifice scalability because all of a sudden your payload, the work you're asking to the network, is done by everyone instead of being done by just a single party. Now, the big question is, this is obviously a trade-off, but it's a trade-off worth doing, right? I mean, blockchains have had traction for the past few years. Obviously, there's some value here. So how do we keep that, and how do we scale this? How do we make it available for the next billion people, right? So this is the current state of affair, right? You have trusted central parties, delegated in accountability, and distributed networks or replicated networks where everybody verifies all the transactions but with little scalability. What can you do to solve that problem? Well, one solution, okay, is to trust the big computer. Then what it is you can do in a blockchain network. The first option is obviously to increase the gas limit or increase the block size, right? Do you have IDs or examples of blockchains that chose that path? Looking at the chat right now, I think there's a bunch of them. Yeah, sure. So Fred is saying Solana, Diego is saying BSC. Yes, those are both valid examples, right? You just crank up the size of the block, and then you can get to do more transactions. However, that doesn't really solve the problem. It merely pushes it down the road, because what happens when you crank up the block size is actually that you require to every participant of the network to get a bigger machine. And I mean, after all is said and done, that's basically what you're doing. So if your network aims at having as many people as possible validating it, which is what you want in inclusive accountability, then you are slowly moving away from that because you're making it more difficult for people to validate the network because all of a sudden they need more resources. And here it's really interesting to see where each network puts the slider on the scale. You have networks like Bitcoin who want the network to be validated, to be able to be validated by a single cell phone. Networks like Ethereum decided that laptop is good, but these are not very well specified, and everyone kind of disagrees into what the limit should be. And once again, it doesn't really scale because, I mean, you're always going to be limited by the smallest machine you want your network to be accessible from, right? So then we have the other possibility, which is fraud-proof rollups, for example, like Arbitrum, Optimism. And what they rely on basically is a bunch of big computers doing the computation, while having everyone, if you want, have the possibility to audit the transaction and submit a fraud proof if they deem a fraud that a fraud happened. It works, but it still requires some trust. Specifically, you're assuming that somebody is watching the network, and most users won't be watching the network. So you're, in a way, relying on a network of validators. Okay, I'm going to take a look at the questions if there are some. Can you explain the difference between an optimistic rollup and a ZK? Yeah, I'm going to explain it in a sec. Okay, so now what exactly do ZK rollups do? What a ZK rollup does, basically, is that it delegates, it relies on a cryptographic primitive that is a proof of computation. I want you to think about that primitive kind of like the way you think about hashes, right? We all know more or less what a hash is. It's kind of like a digital fingerprint. You know that you put some data in and you get a specific output that is always the same length, and there's only one per data that you will input, and it's sort of unique, right? You don't necessarily know how it works, but you know that this works, right? Zero knowledge proofs and ZK Stark proofs are the same kind of tool where basically they're a mathematical tool to allow you to prove that a certain amount of computation was done correctly without you having to do the computation. I'll say that again. It's a way for party A or Alice to prove to party B, Bob, that she did a big amount of computation that led to a specific result. And she can send to Bob the program, the results, and the proof of execution that will give to Bob a cryptographic guarantee that the program was run correctly and ended at these results, and the proof will be a proof that there's no way she could have spoofed those results, right? It's kind of like another example I like is kind of like proof of work. If you're familiar with how proof of work works, when somebody submits a specific proof of work, right, a specific hash that has specific characteristics, you're confident that some amount of computation was spent to generate it without you having to actually do these calculations. Where here it's kind of like the same. I will give you a proof that the program executed correctly, and you'll know that the result is correct without you having to run the program. Okay. So that the big difference here between optimistic rollups and ZK rollups is, I'll come back to this in a sec. Okay, so basically the way it works on StarkNet is that you have a bunch of people who are what we call sequencers and provers, but we'll focus on the provers that will gather transaction and prove the correct execution of these transactions, gather them in a proof, and send that proof to Ethereum. The cool thing about these proofs is that since they're mathematical tools, they can be interpreted by players outside of the blockchain, but also by the blockchain itself, and Ethereum is able to validate this kind of proof. So the big difference between ZK rollups or availability rollups and optimistic rollups is that availability rollup will basically, when you do a transaction on an availability rollup, the data is posted on Ethereum and it is available on Ethereum, but it is not interpreted by Ethereum. In other words, your transaction is not executed by Ethereum. The security of the system relies on the fact that somebody will execute this transaction off-chain and verify their validity, and that if one transaction is not valid, then a proof can be submitted to Ethereum to say, hey, check that transaction here to check that everything is correct. And if something is not correct, then the person who posted that transaction gets slashed. On availability, that's why they call optimistic rollup, right? Because you take into account the transition without actually verifying it, right? You expect somebody will check it, and if there's a fraud, somebody will prove it. Availability rollups are different in the sense that the transactions are executed and a proof is generated and the proof is validated by Ethereum. So before the state change is taken into account, the proof is verified. Is it true that in the end, state optimistic rollup will be cheaper than ZK, but by what order of magnitude? Also, how do you think the fees will get without sharding? I think it's really hard to predict the future, and I think that especially with the Ethereum roadmap, it's hard to know where we're going, right? Things always change and get delayed and stuff like that. So I can't speak for what will happen in the future. I can speak as to what can happen now. And right now, rollups are significantly cheaper than optimistic rollups. And also, I want to mention that in a way, we're all on the same team. We're building extensions to Ethereum, right? So I think in the future you'll have both optimistic rollups and ZK rollup, and both will serve different needs, but it's hard to know exactly which one. Okay. So going back to my presentation, validity proofs are basically a way that you prove the execution of some transaction outside the chain. You generate a proof, which is a cryptographic value that you send on chain with the result of this execution. And the proof can know that the execution happened correctly. So that's the example I took a bit earlier, proof of work. So you get to prove that some amount of computation was proved to look for a solution. You get two parties, the prover, so the people who will actually do the work, and the verifier, the people who will verify that the proof happened, which is the full nodes of the network, right? It will verify that some amount of work was spent mining a block. For ZK Stark proofs, basically, that's how it works, right? You send some transactions to a prover. This prover will execute the transaction, generate the proof, and then send it to the verifier. The cool stuff here, if you're paying attention, is that when you want to execute a transaction on Ethereum, you send it to the whole network and everybody will have to execute your transaction, right? Everybody will have to do the calculation you're trying to do. That's how we get to a common state of the network. Everybody does the same work. Here, you just send it to one party, the prover, and the prover can execute the work and then have everybody verify it and have very strong guarantees as to the result without actually doing the work. That's what's very powerful, because something I didn't mention is that verifying a proof is less expensive computationally speaking, than actually executing the work. And another really cool artifact is that the verifying cost scales logarithmically with the amount of computation you're trying to prove. In other words, the bigger the load on the prover, the bigger the load on the verifier, but it grows more slowly than the load on the prover. And this is why you get this counterintuitive thing that on a ZK rollup, the more transactions are sent by users, the cheaper by transaction it gets. Okay, I'm going to take a look at the questions because I like to get these questions little by little. So, how difficult is it to learning to build on StarkNet? I'm not going to lie, it's not that easy. It's not that easy because it's inherently more difficult to learn with Starks. It's not easy because it's still alpha software and there's still a lot of tooling to build. So it's a land of opportunity. You guys are on the frontier, push it. Esto es mucho para mí, pues si tienes preguntas en español, no dudes en preguntarlas. ZK Starks are resistant against quantum computers. Yes, well, that's something that is often put out. So ZK Starks, the cryptographic primitive that allows you to execute a program and generate a proof for its correct execution, are built on top of one existing cryptographic primitive, which is non-collision in SHA-256, right? And SHA-256 has been mathematically proven to be quantum resistant, which is why we say ZK Starks are quantum resistant. It's not the case for other proof systems, such as, for example, SNARKs, which are based on SHA-256 and ECDSA. And ECDSA, there's no certainty that they're quantum resistant. How is this different from proof of work? It's different from proof of work in the sense that for proof of work, you're proving that something happened, but not the specifics of it. Here, when you're proving execution, you can prove that a very specific path of execution was computed. Basically, when you're generating your proof of execution, you're proving that a specific program was executed correctly. One example I like to take is like, imagine that you're trying to train a machine learning model, right? And it would take you 1,000 hours on your computer to train it. And you need it fast. What is it you're going to do? You're going to send it to the cloud, to Google or Amazon. You're going to spin up a VM, have it run, and then send you back the trained model, right? In that case, what is the guarantee you have that your model was trained properly and that they're not returning just random values? Well, you don't really have a proof for that. You just know that they're not going to do that because they have no interest in doing so. All right. In Cairo, you could basically say, okay, here's my program to train my my machine learning algorithm, and you will get the trained model, and you will get the proof that your program executed correctly and that there's no other result that your program could have yielded. Okay. You can learn more about ZK Starks. Yes. What criteria are taken into account to challenge the transaction besides double spending? So basically, and I'm going to go to StarkNet in a while. Okay, so I'll get back to that question later. Is there enough information in the Cairo paper to implement provers the StarkWare does, modulo the shared prover part? Yes, I think so. I mean, the theoretical basis of Starks is in papers that are open, and it all relies on information that is available. RZK Stark proofs a way to save the global state on the Ethereum blockchain on a regular basis. Oh, you mean the StarkNet blockchain? Yes, in a way. So basically, what happens is that, and I'm gonna address this in a while, right? How do ZK proof works with a sidechain like Polygon? Polygon is a sidechain and it doesn't have ZK proof, so I can't comment on that. How are provers selected? I will go back to that question later on. And then there's a bunch of questions in Spanish. Okay. So yeah, something I want to mention is like, this is very theoretical in terms of StarkNet, but you will see that StarkNet really feels like a network on which you will write a smart contract and send transactions to. here I'm explaining how it works under the hood, but this is very theoretical. You get to the update part tomorrow, right? So I'm going to talk about a bit about I'm going to talk a bit about Cairo tonight still. Can Zikiro be implemented on any blockchains? Potentially, yes, because the really cool stuff about Starks is that since they're mathematical tools, they can be interpreted mathematically. And so technically, like the EVM has opcodes that allows it to verify a proof. So you can submit the proof of computation to Ethereum, and Ethereum natively can verify that the computation happened correctly. Could you do it on any blockchain? I mean, you can do it on any EVM compatible blockchain for sure. And for non-EVM blockchain, there's probably a way you can add opcodes in. I don't know the specifics of it though. There was the question earlier, can you deploy StarkNet to other networks than Ethereum? We could theoretically, but to quote somebody last week was talking about NFT, yeah, but Ethereum is where the party is at. And that's very much the case. That's where everything's happening right now. So that's why we are focusing on Ethereum right now. Okay, back to my presentation. All right, so yeah, so to follow up on that, basically you get a prover, bundling a bunch of transactions, generating a proof and sending it to the verifier. Who is the verifier? Well, the answer is everyone. Everyone will verify the proof. And on Ethereum, if you're validating the chain, if you're a full node on Ethereum, congratulations, you are a StarkNet validator. You are verifying state transitions of StarkNet because all the state transitions in StarkNet are boiled down to proofs of the execution, which are sent to Ethereum, testnet and mainnet since December. And all these state transitions are verified by all the nodes of Ethereum today, okay? So basically, the way we do that today is that for each iteration, so in each time we send a proof, we bundle a bunch of blocks from StarkNet, right? And each iteration generates a proof as well as a state diff. So Ethereum will verify that the updated state of StarkNet was indeed created after successful computation. And the proof is verified also by Ethereum. Can I recover any information about the statement? I'm not sure I understand your question, Matt. If you can add more details, I'd be grateful. How long is the history of ZK proof which can be retrieved? I mean, it's passed as cold data. So, I mean, as long as you have a full node, you can retrieve it, I guess. So, I mean, like the full history of StarkNet is available if you're running a full node on Ethereum. Well, when I mean the full history, that's where things get tricky. And that's why StarkNet is a bit of a different beast than other L1. You will get some information. You will get the information that the blockchain moved from state A to state B, and you will know what was in state A, what was in state B, and you will know that the computation happened correctly, thanks to the according to the rules of the program of StarkNet. You won't necessarily have the details of all the transactions that were involved in that batch, because in the end, does that really matter to you, right? For example, if you have two users making 1,000 transactions, right, with each other, does it really matter what was each transaction, as long as you know that all of them were executed in the right order and were executed correctly, and that the balances at the end were correct, right? Do you have an example of an L1 state update call? Yeah, I'll find one. I'll find out one later on. I don't think I'll find one today, but for sure I'll post one for tomorrow. What is paying in StarkNet? That's an interesting question. And is there MEV in StarkNet? You know, there's a bunch of cool questions here. I'm just going to take note of them because I want to get back to them later on. Yeah. And I'm asking, if there was a dispute about what transactions took place, what kind of things could I discover about them from the proof? So you mean if a transaction was executed or not? Well, you can basically see if the state was updated after your transaction. And also in StarkNet, you have events. So if you include events in your smart contracts, you'll be able, they're committed to the state transition of StarkNet. So you are able to know if an event happened or not. So you are able to know if somebody happened or not. I hope that answers the question. Okay, so what do we do with decay proof exactly? And that's something also we don't, there's a lot of confusion around usually. In general, people are aware of what's of StarkWare. They're not necessarily aware of what StarkX is, StarkNet, or what StarkNet is. And I saw somebody asking earlier what StarkWare was. So StarkWare is a company. StarkWare was founded in 2017 by the inventor or discoverer of Starks, depending on if you think mathematics are invented or discovered. And basically, the cryptographic primitive I'm talking about is basically proving that you know the solution to a specific polynomial without, and you prove that you know the solution without the person on the other hand having to execute the polynomial, which is a long shot from actually programming contracts, right? And so with that primitive tool, we built a smart contract language called Cairo, which allows you to execute provable computation. Cairo is not a smart contract language. It's a general purpose programming language that allows you to write a program that is executed by a prover that will generate a proof and that can be verified by a verifier, right? And once we had written Cairo, we thought, okay, what could we do with that? And we saw that on Ethereum, there was a lot of problems of scaling. And so we started with a simple execution engine, which is called StarkX. And StarkX is basically a set of Cairo tools that allow you to trade NFTs and ERC20s. But you can think of them kind of like white label trading engine. And so platforms such as DYDX are using it, or for NFTs, Sorare. And basically, there are programs that are executed off-chain and proven to Ethereum. And Ethereum can, depending on the correct execution of these programs, interpret input and output and transfer assets. Okay, so this was nice, but writing trading engines is interesting, but sometimes you want to do more stuff. And so now we moved to working on StarkNet, which is network for smart contract programming for general purpose smart contracts, where you get to write any kind of smart contracts you want. And StarkNet, we've been working on StarkNet for about a bit more than a year now. It has been on testnet since July, and it has been on mainnet since the beginning of last December. It is still alpha software, so expect things to be rough around the edges, but it does unlock today tremendous opportunities and tremendous possibilities. So who we are at StarkWare, we're more than 60. Our mission is to bring scalability and privacy. We got a grant at the beginning from the Ethereum Foundation. We're a private company, which is why we raised funds. And what exactly can you do with what we built? Well, and that's where I wanted to mention earlier that, numbers speak for themselves. Currently on StarkX, there has been more than 400 billions in cumulative trading. We've minted off-chain more than 37 million NFTs. And to give you a glimpse of how huge these numbers are, I'm just going to talk about the cost reductions for the people who are using StarkX, sorry. So for those of you who were here a while ago, maybe you've used DYDX in the past while it was still on Ethereum. Doing a transaction on DYDX used to cost between 200 to 300,000 gas per transaction. And today on DYDX on StarkX has implemented more complex logic in their smart contracts. So you can do more stuff, but the cost per transaction has dropped to below 500 gas per transaction, which is a reduction in about 500 to 1,000x, right? And DYDX is fully non-custodial, full ZK rollup. when you're talking about other use cases such as StarkWare or Immutable X, which are dedicated to NFTs, they are using a bit of a different model. I can talk about it a bit later if you are interested in this. And they were able to reduce the cost of minting NFTs by 20,000x. So that's why, I mean, we can talk about what will happen in the future, and it's obviously very interesting, but guys, get excited about what is happening now, because this is not science fiction. This is not an empty promise. This is today. And StarkNet gives you the same kind of availability. And something I want to mention also, because yeah, now we're on StarkNet, is that you have to imagine Ethereum kind of like a toaster where you can toast bread. Toast bread is great, but StarkNet is a oven. So you can make a shitload more toast bread for sure, right? You can make toast bread in much higher number, and you can make toast bread which is much cheaper. But you can also make cake. You can make roast chicken. You can make casserole. You can make a lot of other stuff that you can't just make with a toaster. That's a weird comparison, right? I'm sorry, but what I mean is that scalability comes on two axes. You can either do more transactions of the same kind, or you can do more complex transactions. And that's personally, that's what I find most interesting. Scaling in numbers is really cool. Scaling in complexity opens the door to a lot more stuff. You can all of a sudden do much more things with your smart contracts that you couldn't dream of doing in Ethereum. Another comparison I often like to take is, I don't know if some of you are familiar with a game called Worms 2, right? Where you get worms shooting at each other. If I were to ask you to implement Worms 2 on the blockchain, probably you'd say, oh yeah, sure. So I could have the characters as ERC721. I could count the points with ERC20s. I could have a marketplace for weapons, stuff like that. But there's no way that on Ethereum, you'll be able to shoot a bazooka, calculate the trajectory, calculate the damage on the map, calculate where all the shrapnel will fall, and what is the updated state of the map, right? It will cost you way too much gas. Well, the cool thing with StarkNet is that you can. Instinctively, the rationale is the following. On Ethereum, why can't you do that? Because everyone has to calculate the trajectory, and so this will cost computation time to everyone. On StarkNet, this will cost computation time to just a single party that can scale his machine very, very easily. And so compute time is very cheap on StarkNet. So you can do very much richer applications. Okay, so I hope this is clear. Don't hesitate to ask questions. So StarkNet, where are we at exactly? So we had a nice roadmap we published about a year ago. Our objective was first to have a network where you could execute a smart contract. Then we wanted these smart contracts to be able to interact with each other. Then we wanted the network to be able to interact with L1. And we've basically delivered on all of that. You can program almost, you can program almost anything you want in StarkNet. Will be at feature parity with Ethereum by the, I'd say by the end of this quarter, maybe a bit more, by the end of April for sure. You get to write composable smart contracts. You get to deploy smart contracts permissionlessly, and you get to write rich L1-L2 applications. Something I want to mention that I didn't touch on earlier is that the richness of ZK rollups is that they allow tight composability with L1. We're really an extension to Ethereum rather than a separate network. When you're using a sidechain, for example, basically when you're sending information between the sidechain and Ethereum, what is happening is that you have a set of validators of the sidechain that are designated as the set of validators on Ethereum, and they pass messages. And the chain assumes that since these people are staked in some amount of tokens, they won't pass fraudulent messages because they're incentivized to do so. And that makes sense, but it doesn't really scale well in terms of capital because, if the person have staked like $1 million and you're securing a $50,000 transfer, for sure, they're not going to try and mess you with your payments. If they have staked $1 million and you're trying to pass $1 billion, then maybe it's a bit different, right? So technically, you trust the human or the entity passing the message between both bridges, in the bridge, right? Between the two chains, the sidechain and Ethereum. And Ethereum has no way of knowing that all the computation done on the sidechain was done correctly, right? There's no way they can verify, you can verify a block from a sidechain on Ethereum. Well, in ZK Rollup, that's just not the case. There is no way you can generate an invalid state transition on a ZK rollup and have Ethereum validate it, because you just won't be able to generate the proof and Ethereum won't accept it. So the only way you move the chain forward is by producing valid state transition. And that's a very powerful tool because it allows you to scale the liquidity you'll have between bridges much more in a much larger sense. But also, what I really like, it's a bit convoluted, but it's that natively the chains can talk with each other. Ethereum understands state transitions and is able to interpret state transitions of StarkNet, right? They can talk without a human in between. The message is passed by a human, but the validity of the message is passed by mathematics, not by the fact that the human is a signer, right? And this gives you a very nice tool as to interoperability between chains. Anyway, okay, so what do we have today in the StarkNet ecosystem? We have 2 full nodes that are in the work. We have Solidity to Cairo compiler. For those of you who don't want to learn Cairo, you can for sure use Warp and use your Solidity code to deploy your contract to StarkNet. There's a block explorer being worked on by Nethermind, and we're collaborating with OpenZeppelin to generate sets of standard smart contract that will allow you to do the same kind of things on StarkNet as you do on Solidity. Basically, you want to use an ERC20, you don't have to write it yourself. You take OpenZeppelin's one, you can customize it your need, and you're able to use battle-tested, audited code. And that's what we're working on. And yep, I have reached the end of my slides. I'm going to go through the questions now. And I've been talking a lot. I don't know if that was clear or if you have questions. Please let me know. Once again, this is all fairly new. This is a fairly new technology, and this is fairly new to us also to make education sessions like this and hackathons like this. So so please tell us if there are things we need to do better and if some things are not clear. So Florian, I'm pretty sure that's Florian, is asking, what is the functional language for the transcompiler? I don't know. So so for the transcompiler, I'm not sure if you're mentioning this thing here, functional language to Cairo compiler. This, I don't know. Regarding the transpiler from Solidity to Cairo, it's basically a transpiler where you go from Solidity to Yule to Cairo. Are there any open source code bases for the StarkNet NFT projects I could look at? You should check. I think Bricks, BRIQS, is open source. Oasis has some code also. Dopwars has, and if you're curious about how to do NFTs on StarkNet, be sure to be here on Thursday because I'm gonna make you sweat. We have a cool workshop where you get to write, deploy, and customize an NFT. So for sure be here. Okay, so there were some questions, and I'm going to address the first one, which is, how is the prover selected? Who is the prover anyway in StarkNet? And I think the broader question is like, right, so how is this decentralized? Is it decentralized? I mean, how does it work? And here, there's how things will be and how things are today. So how things are today is that we made a choice to develop StarkNet and have people test it and hurt it, to be honest, because people have been using it to the max and it has been hard to follow up. But we made the choice of making it available to people as soon as possible. So right now, for the past year or so, we've had people write smart contracts and run them on StarkNet. And validate that the mathematical concept works, that it is possible to operate a network outside of Ethereum that is verified and secured by Ethereum. And we've done that by operating the prover. So today, the prover and the sequencer is very much us. It's only us. It's StarkWare. So we have a bunch of machines that we scale and that we operate to have the network running. Our objective was to validate this. Now we're confident that this works. And the focus of this year for our roadmap is twofold. The first one is that we want to improve the scalability of what we're doing. While it sounds easy to just throw more computing power at a sequencer to make it scale, it's not that easy. It takes a lot of engineering time to optimize and to accommodate the needs of 1,000 apes. And we're working on that. So our objective is to make the system, to augment the throughput of the system. Somebody was asking about latency. I'm not sure if that's this, but that's what that's something we want to build. And so by the end of the first semester, we want to be able to process 10 times the amount of transaction that there is on Ethereum at 100th of the cost. So that's our objective for the first half of this year. And we'll keep working on that, and we'll be able to do more than this in the future, for sure. For the second half of, and by the end of this year, we also want to have a road for decentralization. So basically, we want to decentralize the network. We're not building an enterprise blockchain because do I really need to explain it? I think it's fairly clear for everyone that public blockchains are way more interesting than a permission solution. So that's where we're building, and we're looking at decentralizing it. Our forte is cryptography and Stark proofs. We are not consensus experts, so probably we'll reuse or try to reuse existing consensus algorithm that will allow for the prover to be selected randomly depending on criteria that we'll still need to define. This is a very interesting discussion that you should join. You can join it on our forum and see how things happen and submit your ideas and proposals, because they're very valuable, and we actually rely a lot on these to make the system better. So that's about decentralization. So the following question was about MEV. Is there MEV in StarkNet? So I'll address this. I'll address another point and then this one actually. So the first one is, when people say zero knowledge proofs or zero knowledge or ZK rollup, oftentimes people think, oh yeah, it's confidential, right? It's confidential transactions. And it's not the case. Bottom line is, transactions on StarkNet are not private, full stop. And the rationale is simple, is that we use cryptography in order to compress transaction, not to obfuscate what is in those transactions. It is possible to do so. We just haven't gotten around to doing it yet, and we focused on scalability. That being said, privacy solution can be implemented on StarkNet, and I myself, I'm super excited and looking forward to this, because I think you'll get to do a lot of cool stuff. But Bottom line is transactions are not private on StarkNet. And if transactions are not private, it means that for people running a full StarkNet node or sequencer, then they get to see all the transaction. And yes, they may get to extract value from MEV. So today, MEV on StarkNet is, I think, largely a theoretical problem because we are the only sequencer and the only prover, and we're not in, I mean, we don't spend brain power doing that because because we have other things on our plates, to be honest. Will MAV be a problem on StarkNet in the future? It will be a topic, for sure. It will be something people will need to pay attention to. And yeah, will it be a tool for decentralization? Kind of like some network think MEV could be a way to pay for prover and sequencer? I don't know. Will there be techniques to mitigate it? Maybe. Then again, for that, do join the discussion. This is a very interesting topic, and we're super interested in hearing what you can come up with as a solution. Then somebody asked, what is the cost of a transaction on StarkNet? So as I mentioned, we want to process 10 times the amount of transaction on Ethereum within the next 4 months. And we want the cost per transaction to be 1/100th of what it costs on Ethereum. What is there a limit to that? I mean, that's what we aim right now. I want to give you 2 insights. The first one is that on StarkNet, some things are more expensive than other. For example, when you're doing a transaction on Ethereum, you will pay if you store something on the blockchain, and you will pay for execution, like computing time. On StarkNet, storage still is expensive because you still store that on Ethereum. So your transaction, if you're storing variable, this will have a cost. But execution, since it is done only once by only one player, even people who catch up with the chain don't need to re-execute this computation because it has even proven to be valid. So your computation is really done only once. Then this means that execution and computing is virtually free for now. So the cost of your transaction will mostly depend on how on the amount of storage you will have. And now for long-term scaling, long-term scaling and cost, and it's also related to another question. Is there anything stopping non-ETH L1 from submitting ZK proofs to ETH? It's not exactly the same question, but it's related. Right now, you can generate a proof and have Ethereum verify it. You can't generate a proof and have StarkNet verify it yet. But this is something we're working on, and that will ship in the next few months. Yeah, I don't want to commit to a timeline here because I don't want to say something I'm not 100% sure of. But my hunch is that it's in the coming months. Basically, it will be the ability to generate a proof and have StarkNet verify it. And once you're at that point, you can really think. You don't just think in terms of layer 1 and then various layer 2s. You can think about a chain, right? Layer 1 with a layer 2, and then another layer on top of that one, and maybe another one on top of that one, and maybe they talk with others. And so you really get the multi-chain feature you imagine of, but they can talk natively. And the cheaper you want your transactions to be, the higher up the chain you are. And what's really cool is that these chains can all experiment with different consensus model, since the execution of transaction is guaranteed and is verified. You don't need to trust too much the sequencer, to be honest, or you don't need them to stake too much. You can just basically, I mean, if they submit a valid proof, then the proof is valid. There's no discussion around it. And so you can imagine a future where, depending on your proximity to L1, you will pay different fees, and it will be really up to different applications. Now, somebody's saying, is there anything to stop non-ETH L1 from submitting ZK proofs to ETH? I mean, aside from rewriting your entire code base so that the execution of your blockchain is provable, no, nothing is stopping them. But that's a big ask. As the organizing company, what do you want to see? As in projects from the hackathon, not just tracks. That's a good question. So I'll come back quickly on the tracks first. The tracks, basically, one is for ZK, I mean, for StarkNet apps, StarkNet native apps. So apps that fully live on StarkNet and can implement any kind of stuff they want on StarkNet and use other apps and stuff like that. The second one is L1-L2 apps. Here, basically, I want you to realize how an incredibly powerful tool the messaging bridge between StarkNet and layer 1 is. You can basically have execution of something happen on StarkNet, and this sending messages that are interpreted by L1. And L1 can use these messages in smart contracts without having to trust a human that this message is valid. This basically means that you can have a DAO where the assets live on L1, all the decisions are taken by governance on L2, and all the decisions taken by governance are then sent natively with DK proofs to L1, and these decisions are enacted. You can have the muscle, the liquidity live on L1, and the brain living on L2. And I think that's a really exciting thing. And coming back to what I want to see in projects from the hackathons, not just tracks, I want to see you have fun. I think this tool is, if you've developed smart contract in the past, this will open so many doors to you in so many horizons of things that you just thought like, oh no, there's no way I can implement that. It's too expensive on a blockchain. All of a sudden, this is possible. You're at a frontier, and thousands of things are available. I can't tell you what I want to see built because I don't know what can be built. That's up to you. And I want to see you get excited about exploring this frontier, to be honest. I also want to see that if you get excited about things and you want to work on StarkNet related stuff, do reach out. We for sure can help you do cool stuff. So let us know if you've built cool stuff or if you want to build cool stuff on StarkNet. How important is understanding ZK to build apps on StarkNet? I would say that it is about as important as understanding ECDSA signatures in order to write Ethereum transaction. It's nice, but it's not required. Does that make sense? So would StarkNet replace the need for oracles like Chainlink? Not really. You still need somebody to tell the blockchain what happened outside. So as long as it's something that is happening outside the blockchain, you will need an oracle. Yeah. If you have more questions, please let me know. I'd be more than happy to answer them. And going back to the program of the hackathon, today I explained to you what it is in a nutshell, right? Tomorrow we'll see how to write smart contracts, and you'll see that really it will be very familiar. Writing smart contracts in Cairo is difficult, not because of Cairo. It's difficult because writing smart contracts is difficult, right? Having the state of mind of having a network execute your payload and how it works and stuff like that, that's weird. Like, to a lot of programmers, that's weird. If you have that, you're already like, Cairo will be a bit different for sure. It's a bit of a different syntax, but I'm sure you'll get a grip of it. And if you don't, let me know. I want to know where it is too difficult so that we can make it better for the future. Cairo is still very much rough around the edges, but it will only get better. Okay. Andy is asking which criteria are taken into account to verify a transaction batch. So basically, StarkNet works like a separate network. So it has transactions and blocks. And every so often, we take a bunch of blocked of blocks and generate a proof that is then sent to L1. The frequency of these blocks and the frequency of this batching into transaction is not preset. It's something that we're adjusting with time and that we will adjust in the future. So right now on testnet, it's about like there's a block every 2 minutes and there's a proof every 2 hours, I think. And for mainnet, there's a block. There's not a lot of activity on mainnet, so we have a block every 2 hours, I think, and a proof every 12 hours, something like that. But with the usage, this will come down significantly. Florian is asking, how easy is it to interface StarkX and StarkNet? I'd like to interface with StarkWare. So currently, StarkX and StarkNet are siloed. You can't get them to communicate. So the objective of the hackathon of today is really StarkNet. So unfortunately, StarkWare is out of scope for now. And in the future, when we'll have the availability to verify a proof on StarkNet, you'll be able to verify. I mean, StarkX will be verified on StarkNet, and you'll be able to interact from StarkNet to StarkX. But that's not here today. I think I'm done. I hope I didn't lose too many of you. And thank you.
No, you didn't. Henry, thank you so much. That was really insightful. And I think it was interaction from all the hackers was great as well. So thank you to all the hackers. We haven't seen engagement like that for a very long time. So thank you so much. And Henry, that's just credit to your presentation. Yeah, I mean, if there's any last minute questions, I'm sure we got 1 more minute, so we could probably have 1 more. Other than that, we can call it quits. So thank you so much, guys, for being here, and see you all tomorrow.
Yeah, and once again, thank to all of you for your time. I mean, your time is invaluable to me, and I really appreciate you being here on a Monday evening to learn more about what we build. And I'm really looking forward to seeing what you can come up with.
Perfect. Thanks, Henry. I think we'll call it there. Really appreciate it.
See you tomorrow.